This video is showing a tool that is generating the production data for shim plates. The tool is checking if shim plates are standard shim plates according to definitions that are existing. And if so, it's generating the production data and it is exporting the production data to system drawings that contain a representation, a sketch of the shim plate type in the system drawing, and a table for the production data. The tool is integrated into the group tool. It's a customized version, so it uses the shim plate definitions of a client. The design of the tool follows the design that I explained in the video production data for standard parts concept that you also find on our webpage. And all tools of that type have a check part and an export part, because in between the positioning has to be done. The checking of the parts can be done after the allocation of the group type name to the parts, if make standard part check is set, or the independent command check can get used. I'll use a command. We have to load the data into the tool first. We have to select the parts, and then we can do the check. We have to select the parts that we like to get checked. The first step that the tool is doing, it's sorting the shim plates according to their material. That is because we decided after discussions with our client that material is the first criterion, because all shim plates on a system drawing should have the same material. There should be no material mix on a system drawing. So material is the first criterion, then the geometry of the parts. We can continue, and we see the tool is starting to check. What is checked is the geometry of the created parts, not the modifications that were used to create the parts. So it's really the final geometry that gets checked, no matter how the parts got created. We see that most of the parts got colored red, and according to the color error codes that we have here, red are okay, red are standard parts. We have a look at them and we understand the pattern that the shim plates have. Obviously, for 2 rows of bolts, and each pair of bolts has a slot, and the first pair has for 1 bolt a short slot and a drilled hole, so that 1 bolt is securing the shim plate in its place. Also, if we look at one of the standard shim plates, we see that it has the standard part entry in node 1 of the group data. It says STP standard part shim plate, the type, Q235B, the subtype, and 1, the subtype. And we see that the part is positioned. It has one of those standard part position numbers that consist of 2 parts, a regular group number that is also referring to the system drawing number. So it's easy to find a part in the model, apart from the model in the system drawing. And the second part of the number is the index of the part. That's the index of the part in the table. The other colors in here are blue, and blue says hole geometry is not okay. If we look at parts, we see the pattern is totally different, so obviously the pattern of this shim plate is not covered. This shim plate seems to be okay, so I think it's probably a tolerance problem, that it might be slightly off. The tolerance for the slots is 0.2 that is used. And what else? This shim plate, for instance, has a different slot pattern, so it's not standard. We can confirm that message, and we have shim plates of another material, and we see they are blue. It's not a standard pattern. Say OK, And because all shim plates are obviously positioned, we can do the export. We'll do it right away. We have to use the position numbers, and also we have to have a project number. We select the parts. The tool is doing the sorting according to material first, and then the parts get checked, the parts get rechecked if they are standard parts. If necessary, the tool is editing the node 1 entry in the group properties, it's changing it or it's deleting it. And then the tool is checking if all parts have correct position numbers, that is, if standard parts have standard part position numbers and if ordinary groups have ordinary position numbers. Then it also checks if standard parts that have the same base number are of the same subtype, because a mixing of subtypes on a system drawing is not possible, is not allowed. Everything seems to be fine, so we continue. The tool is generating the production data, it's creating the necessary sheets, and it's loading the data into the table. We see the sketch for the shim plate with the labels for the dimensions. And if we look at the table, we see that the table contains all necessary data. The quantity of the parts, position numbers, name, die stamp, the material, the thickness of the shim plate package, the dimensions, length, width, and the dimensions for the holes and the slot. And also we see that there is, for every part in there, there's a sketch that shows what the part has to look like, and these sketches really help the shop to make the part. There is another system drawing created, and that's I would say a regular shim plate, a shim plate that has only drilled holes. And we also got all necessary data in here, and we have a sketch what the shim plate has to look like. So we have to save the drawings. That's it. The production data is generated and documented. The non-standard shim plates still need to get detailed, but anyway. There are videos for all tools of that type that we created so far, for tool for gratings and kick plates and also handrails on our webpage. So if you're interested in them, if you'd like to have more information, have a look. Also, there is contact information on our webpage in case you like to get in touch with us.